On BYJU'S Exam Prep, India's most comprehensive preparation platform for all the engineers. All the candidates who are joining me live, just quickly confirm your presence in the comment section and tell me whether my audio, visual quality, everything is clear so that we can start with the session. Till you are going to report me this, let me just brief you what is the ideal duration and what is the agenda for today's session. The ideal duration for today's session is going to be approximately 45 minutes. And the agenda or the outcome of the session is that today we are going to talk about some of the important questions and concepts related to the concept of armature reaction and commutation in case of DC machines. Is it clear, everybody? Just tell me in the comment section. Audio, visual, everything is clear, and just everybody who is joining me live, just quickly like, share and subscribe the session. Like it, share it with your friends and colleagues, and subscribe to BYJU'S Exam Prep if you have not subscribed till now, so that you do not miss any of the important session. Yes, everybody, just tell me in the comment section. Everything is clear? So let us start with DC machines, but before that, some of you may be joining me for the first time, so there is a brief introduction about myself. My name is Ashutosh. As you can see on the screen, I have 11 plus years of teaching experience, completed MTech from BYJU in 2010. I have written a couple of books also, and these are my areas of expertise. Before we start, a very important information for all those candidates who want to ace GATE examination in the very first attempt. Your favorite Faneen sir is going to take a session on 26th of July 2022, and the timing is going to be 8 p.m. So just set your alarm right for this session. This session will tell you that how you can qualify GATE examination with a good rank in the very first attempt. Let us discuss the first question. See, the first question says there is a 4-pole DC machine having 100 armature conductors. He is saying the EMF induced in each armature conductor is 2 volts when the speed is also given 1000 RPM. He is saying the maximum allowed current in each armature conductor without overheating is 10 ampere. So let us first understand what is the meaning of this statement, because this is the key statement for this question. He is saying the maximum allowed current in each armature conductor. So what is armature conductor? Let us first understand. We define a winding like this. This is going to be a single turn winding. This is a single turn winding because there is only one closed loop. Only one closed loop is formed, so we are calling it as single turn winding. This winding is going to have 2 conductors, A to B and C to D, and these are the overhang portions. These are the overhang portions. You please understand that overhang portion is not going to take part in the energy conversion process for your machine. Only the conductor is going to take part actively in the energy conversion process. That is, AB and CD, the 2 conductors are going to take part or participate in the energy conversion process. So if you see, your coil looks like something like this. Yes or no? Suppose this is the coil, this is the winding. Now this winding, the current passing in one parallel path, because there can be a number of parallel paths, and because it is a lap machine, because it is I think it is mentioned here, 4-pole DC machine. Okay, both the cases you have to consider. You have to consider both the copper losses for lap and wave bound machine. So you know, for the lap bound machine, what is the number of parallel paths? It is equal to number of poles, that is 4. And what is the number of parallel paths for the wave bound machine? It is 2, irrespective of the number of pole. So if you observe, suppose we talk about the lap winding. Suppose we are talking about lap winding. So for the lap winding, your winding should be something like this. There will be 4 parallel paths. If you draw it in the form of a circuit, it is going to be something like this. Now he is saying the current passing in one conductor. Yes or no? The maximum allowed current passing through a armature conductor. So where is your armature conductor? This is your armature conductor. It means the current passing through each armature conductor is nothing but the current passing in each turn of any parallel path. So he is actually giving you this value of the current, and this value of the current he is saying is 10 ampere. It means in every individual parallel path there can be 10 amperes of current. So if there are 4 parallel paths, can you tell me what is the total armature current here? Everyone in the comment section, can you tell me now what is the total armature current you have? It is going to be 40 amperes, and this is for the case of lap winding. Let us discuss the case of wave winding. In case of wave winding, you have only 2 parallel paths, something like this. He is already giving you what is the maximum allowed current in each parallel path. It means he has already mentioned the current in every individual parallel path is going to be 10 amperes. So what is going to be armature current in this case? That is 20 amperes. Directly you can write. Once you know the current in both the cases, and you have to compare the losses. What are the losses? I square R, that is the copper losses. Yes, Mr. Khan. Good evening, good evening. So I have calculated till now what is the armature current for the wave bound machine, and that is 20 amperes. And what is the current for armature current for lap bound machine? That is 40 amperes. Now I want to relate the armature resistance for lap and wave bound machine. How I can do that? Let us try to go inside the armature of the machine. Let us try to go inside the armature of the machine. Suppose this is the armature. These are the brushes. These are the external terminals. Now inside your armature winding is going to look something like this. I hope it is visible to all of you. There will be a number of parallel paths. In each parallel path, every single conductor we are representing with a small resistance and a small EMF induced in that conductor. For example, if you see this, yes, this conductor, whether it is AB or CD. How we are representing this AB or CD? If you see this AB or CD, we are representing with a small resistance and with some EMF induced. This is a small r and this is a small e. This is how we are representing the conductor in our winding. Now, if you want to see how we are going to relate the armature resistance, let us try to understand. If I tell you the total number of armature conductors are Z, so can you tell me what is the number of armature conductor in one parallel path? How many number of parallel paths? 1, 2, up to what? A. A is the total number of parallel paths, whether it is a lap bound or wave bound machine. So if the total number of conductors you are going to divide by total number of parallel paths, you will get the number of conductors in one parallel path. And what is the resistance of one conductor? That is small r. So if there are Z divided by A conductors present in one parallel path, what is the resistance of one parallel path? That is going to be multiplied by small r. But such parallel paths we are having A in numbers. There are A number of parallel paths like this. So what is going to be the whole equivalent resistance for this circuit? It is divided by A. So this is how you are writing the armature resistance of a DC machine, armature winding. If you simplify this, it is simply going to be R into Z upon A square. Is it clear? Yes, Shubhadeep, how are you? Welcome to the session. Now this R is the constant, whether it is a lap bound machine or wave bound machine. This R is a constant and number of conductors is a constant. The only thing that is changing in terms of lap and wave is the number of parallel path. So can I write, my friend, RA is inversely proportional to the square of number of parallel path? Yes. Now you can very easily relate the losses. If I write IA square, that is for lap, RA lap divided by IA square wave multiplied by RA wave. What is the current we are having for the lap winding? It is 40. Take the square. Okay. And what is the current we are having for the wave winding? It is 20 square multiplied by, what is the ratio of RA lap and RA wave? It is going to be 1 upon number of parallel paths for the lap winding square and number of parallel paths for the wave winding, that is 2. So this is going to be 2 square. Is it clear for everybody? Just try to solve this. If you see, it is going to be 2, okay, and this is going to be 2. So I think it is going to be 4 upon 4, that is 1 upon 1, 1. So the ratio of armature copper losses for the lap winding and wave wound machine is going to be same. Now this is what we have discussed in terms of the conventional approach, how we are going to deal with this problem. But you understand, lap wound machine and wave wound machine, you are just changing the arrangement, the number of parallel paths. Are you getting that? You are just changing the number of parallel paths. You are not giving input any active source in that circuit, in that network. So you can understand, if you have n number of resistances, now whatever arrangement you want to do, you can do. Either you can change the voltage or you can change the current, but power will remain same now. And loss is nothing but a power. So if you have this intention in your mind that your machine is like a black box, inside there are some resistances. Now whatever arrangement you do, the loss is not going to be changing. If you increase the voltage, current will be low. If you increase the current, voltage will be less. Are you getting this or not? Parallel and series arrangement. Is it clear, everybody? Let us go to the next question. A 4-pole lap wound generator is running at 900 RPM. If the self-inductance is this much, armature current is this much, number of commutator segment is this much, width of the brush is this much, what is the reactance voltage? Let us understand first what is reactance voltage. How we are defining the reactance voltage? It is defined as L di by dt. Everybody is clear with this? Yes, rest of the things are not changing. Prasanna Kumar, rest of the things are not changing. Are you getting this? We have a design, we have everything, just we are changing the arrangement in case of lap and wave wound machine as per the question. Now see, reactance voltage we are defining as L di by dt. Now what is this L? What is this I? Let us try to understand. See what is happening. Let me just show you one diagram so that you understand it better. Suppose this is your DC machine. These are the main field poles. There is the north pole and this is the south pole and this is the brushes. These are the external terminals. And suppose for the generator, the direction of rotation is like this. These are your, suppose, armature conductors placed in the slots in the armature. These are the armature conductors. I hope you must be aware with this. Suppose we are talking about the generator. So what is the polarity or what is the direction of induced EMF or current in these armature conductors? Everybody just tell me in the comment section, do you know how to find it or not? If you know, then my job will be easy. And if you don't know, then I have to tell it, because without understanding this, we cannot proceed for this question. Do you know how to find the direction of induced EMF or current for these armature conductors in DC machine? Yes, by using Fleming's right hand rule. What is Fleming's right hand rule? Index finger in the direction of main field flux, thumb in the direction of torque, force or the movement, and central finger in the direction of induced EMF or current. Let us apply this Fleming's right hand rule. Now, if generator is rotating in this clockwise direction, it means all the conductors which are at the north pole side, they will be having a torque in this direction. And all the conductors which are under the south pole, they are going to have a torque under this direction. So first I am applying this Fleming's right hand rule for the armature conductors under the influence of north pole. Index finger in the direction of main field flux. What is the direction of main field flux? It is north to south. Thumb in the direction of force, torque or movement. The movement is upside. So what is the direction of central finger? The central finger is going into the plane of the screen. Into the plane of a screen. Just do it yourself. So what is the EMF direction you are getting? Cross in all the armature conductors which are under the influence of north pole. If you apply the same law, Fleming's right hand rule, for all the armature conductors under the influence of south pole, you will get a dot. Yes, you will get a dot. Dot means EMF or current coming out of the plane of the screen. It is important to understand this. Now see what is happening. This is the armature and this armature is rotating. It is a generator. It means after some time, this conductor is going to reach this position. Yes or no? When it is going to cross the brush, this conductor after some time will reach this position. Yes or no? When it crosses the brush, there is a complete reversal in the direction of current in this conductor. Before the brush, it is into the plane of the screen, and as it passes through the brush, the current direction becomes out of the plane of the screen. Is it clear? Are you able to follow this? Are you able to follow this or not? So my friend, this sudden, complete reversal of current in the commutating coil is called commutation. This is the process of commutation. I hope it is clear for all of you. This is the process of commutation, and you know that commutation is a very important phenomena in case of DC machines, because DC machines are like AC machines only. The only difference is the process of commutation in general, if we say in terms of the operating principle or theory. It's not just current reversal, my friend, it is the complete reversal of the current. Now, when the current is going to be changing suddenly, because it is an inductive coil, this commutating coil is inductive in nature. This commutating coil has a self-inductance L. And because of this self-inductance, there is a induced voltage. That induced voltage is L di by dt, and this is what we are calling as reactance voltage. What is the use of reactance voltage here? See, reactance voltage does not have any use. It is the problem. What this reactance voltage is trying to do? Reactance voltage will try to oppose this sudden reversal of current. I hope you are getting this. Is it clear? So we are interested in this reactance voltage because it can produce sparking and a short circuit at the brushes, and it may damage your brushes also if the insulation is not that much effective. So if you see how we are defining this, L is going to remain as same. Let us see this current reversal diagram. This is time t. This is the current in the commutating coil. So initially it is plus IC, current in one parallel path. After that it is minus IC because the direction has reversed. And from this to this, we have this type of transition. So now you can understand this is what we call as period of commutation. This is what we call as period of commutation, means time period for commutation. This is the time in which current becomes from plus IC to minus IC. So what is the total change in current? It is final minus initial. So it will become minus IC minus IC. What is the time period? That is the commutation period. So it will become minus 2LIC divided by TC. L is given in the problem. What is IC? IC is current in one parallel path. That is the armature current divided by number of parallel paths. What is armature current? 108 amperes. What is the number of parallel path? 4 pole lap bound. So lap bound means number of parallel path equal to number of pole, that is 4. So this is going to be 28. So you know what is the value of current in each parallel path? What is the only unknown here? The only unknown is the commutation period. So in this problem, basically you have to discuss how to find the commutation period, and it is a very interesting problem. Just try to observe here. What is given in the question? In the question he is saying the generator is running at 900 RPM. What is the meaning of this statement? What is the meaning of this statement? 900 RPM means there are 900 revolutions in 1 minute. Yes or no? 900 revolutions in 1 minute. So can you tell me the time for one revolution? It is going to be 1 upon 900 minutes. But we are actually interested in seconds. We don't deal with minutes. So it is going to be 60 divided by 900 minutes. This is the time period for one revolution. Now please understand what is the meaning of this statement. If you closely observe your machine, this armature is also going to have the commutator. Your commutator is going to be something like this. I am just showing you. It's not the exact image. You can say this is going to be your commutator. I am just telling you. I am very crudely, I am telling you, okay, don't take it like the real picture. Just telling you that your commutator is also rotating with the armature. These are the commutator segments. So if my friend, you are standing here, if you are standing here and you are watching here, so in one complete revolution, how many commutator segments you can observe? All the commutator segments, because there is one complete revolution. So how many total commutator segments you are having? That is 55. It means you know the time taken to cross the 55 commutator segment. We have already calculated 60 upon 900, and this should be second. This should be second, my friend. So can you tell me the time for crossing the one commutator segment? Yes, it is 60. 900 divided by 55. But you know how we define commutating period. Commutation period is defined as the time period for the commutating coil to cross the brush or the brush width. In general, we can say. It means you have to see how many commutator segments are equivalent to the brush width. So that is given, width of the brush is 1.74 commutator segments. So if you know the time for crossing one commutator segment, can you tell me the time for crossing 1.74 commutator segments? Yes, just multiply this by 1.74. So it will become 1.74 multiplied by 60 and divided by 900 multiplied by 55. Just solve this. This is your commutation period and put it here. Put it here and you will get your answer. Everybody just tell me in the comment section, are you able to follow this or not? Yes, everyone. And everybody just hit the like button. Just like it, na? Like the session and share it with your friends and colleagues so that more and more people are going to be benefited. Is it clear for everyone? If you have any doubt, you can ask me a number of times. Okay? Yes, Prasanna is following. Any doubt, you can ask me n number of times. But you should understand the concept that is more important. Okay. So I think now you can solve it. See the next question. Calculate the number of conductors on each pole piece required in a compensating winding for a 6-pole lap-wound DC armature containing 286 conductors. The compensating winding carries full armature current. What is the basic idea of compensating winding? Let us first understand. Suppose this is your machine. Okay. Suppose you have a 4-pole machine, something like this. Suppose this is north, this is south, then this is north, then this is south. Now, compensating windings are going to be placed in the slots made in the pole face. Slots made in the pole face. And compensating windings are connected in series with the armature winding. Connected in series with the armature winding. And what is the purpose of having compensating winding? Compensating winding compensates the cross magnetizing effect of armature reaction under the polar region. What is polar region? Because compensating winding is only present in the polar region where poles are present. And what they are compensating? The cross magnetizing effect of the armature reaction under the polar region. Is it clear? Now please understand. What is happening here? These compensating windings are carrying the same current, that is the armature current. So they give rise to ampere turns or the MMF, which actually compensate this cross magnetizing effect of the ampere turns of the armature winding. So what is the basic idea? The basic idea is that your compensating winding, ampere turns of the compensating winding, it must be compensating or nullifying the ampere turns of the armature winding per pole. Yes or no? Ampere turns of the armature winding per pole. But this is the total number of, it is the total ampere turns of armature winding per pole. But we only want that ampere turn which is under the polar region. So what we are going to do, just see here. This is what we are defining as pole arc. What you are finding as ampere turns of the armature winding per pole, that gives you ampere turns of the armature winding for one pole pitch. You know what is pole pitch? This is pole pitch. This is pole pitch. The peripheral distance between two similar points on the adjacent pole. The peripheral distance between two similar points on the adjacent pole is the pole pitch. It means what you are getting is for pole pitch, but you want only for pole arc or pole face. So we have to rationalize this expression as pole arc upon pole pitch. Is it clear for everybody? Now how we define ampere turns of the compensating winding? Ampere turns means number of turns multiplied by current in each turn. So how we define the number of turns? If you have total ZCW conductors in the compensating winding, how many conductors you require to make one turn? You require two conductors, A to B and C to D. You require two conductors to make one turn. It means if you have ZCW, this much number of conductors, what is going to be number of turns divided by 2? What is the current in each turn? Because compensating winding is connected in series with the armature winding. So this is equal to armature current. What is the ratio pole arc upon pole pitch? It is mentioned here in the problem. It is given as 0.7. If it is not given, then you can also take it as 0.7. So this is 0.7. What is ampere turns of the armature winding per pole? If you want, I can explain how we are getting this. But if you know this, then directly you can write. It is IAZ upon 2AP. Is it clear? IA is going to be cancelled. You know what is Z is given. He is just asking you ZCW. So just solve this, you will get your answer. Somewhere around, I think you must be getting 6 or 7. I'm not sure. Just see the calculation part. Is it clear, everybody? Just tell me in the comment section. Yes? Are you able to follow this? If you have any doubt, you can ask me. Prasanna, Mr. Prasanna, how are you? Mudabat, just tell me. See, you have to speak. If you have this attitude that others are going to speak instead of me and they will take care of my requirements, so this is not going to be the case. This word is very harsh. You have to speak for yourself. Are you getting that? So develop this habit. You have to be vocal. You have to tell, sir, I am getting, sir, I am not getting. These are my problems. Solve it. Otherwise, why you are wasting your time? It's not a web series that you can just see and enjoy and get the entertainment. That is what most of the people are doing. But you know it's GATE examination. It's all about content, seriousness, sincerity. This question is on interpole. This I am giving you as part of your homework. Just solve it and give me the answer in the comment section. And I will see who is giving me answer in the comment section. In the comment section of this video, you have to solve this and give me what is the answer in the comment section. Number of poles are not mentioned. Take it as 4. This is 25. Okay. Are you getting this? Now see, this is a very beautiful question. Very interesting question. It's going to clear a lot of your doubts. Find the number of poles. So you have to find number of poles. From 1200 kilowatt generator. So power is mentioned. The average voltage between commutator segment is 15 volt and the armature ampere turn per pole. What is armature ampere turn per pole? Do you know any formula? Armature ampere turn per pole? Yes, we have just seen it is IAZ upon 2AP. That is given as 10,000. So IAZ upon 2AP. You got the first relation. This is equation number 1. Now let us try to decode this statement. The average voltage between the commutator segment is 15 volts. What is the meaning of this statement? Let us understand. This is your commutator segment. This is your commutator segment. In the question he is saying the generator has a single turn coil. What is the meaning of single turn coil? Let us try to understand. Single turn coil. See here. Single turn coil. What does it mean? See. Single turn. 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 Like this. He is giving you the average voltage is 15 volt here. Average voltage is 15 volt. Are you getting this? Average voltage is 15 volt. Okay. And it is a single turn coil. Now, in each commutator segment, whatever voltage is generated, that is nothing but the voltage which is coming across one turn. Are you getting this? Coming across one turn. It means what? What is going to be the total EMF? EMF per turn multiplied by number of turn. Number of turn. Yes, you are right. Mister, what is your name? You are right. It's not Z is equal to 2. Who told you Z is equal to 2? Who told you? Where it is written? What you are doing? This is 2. I don't know what you are saying. If you have any doubt, you can ask me. So what is the EMF per turn? EMF, average EMF across commutator segment is nothing but EMF per turn actually. So that is 15. What is number of turn? Total conductors divided by 2. You will get the total EMF. It's okay, don't worry, person. Never say sorry. Either you don't do something, and if you do something, you prove that this is right. Okay. This should be the approach. So power is given. How you can write power? Yes. If you write E into IA. E into IA. This power is mentioned as 1200 kilowatt. 1200 kilowatt. So I am writing this. This is 1200 kilowatt. What is E? Just now we have seen EMF per turn 15 multiplied by number of turns Z by 2 IA, that is 1200 multiplied by 10 to the power 3. This is equation number 2. Just use these two relations. IAZ you are going to get. Can you solve what is IAZ from here? Yes. Just solve IAZ from here and put it in this equation. Put it in this equation. Okay. Number of poles you have to find and number of parallel path. Is there anything given about the number of parallel path? I think there is one mistake I have done. Just see what is the problem. I have done one mistake. Let me correct it here. Please listen. What is going to be total EMF? Total EMF is going to be EMF per turn multiplied by number of turns in one parallel path. One parallel path. This is what I have missed. Please update it. So what is the number of turn in one parallel path? First we divide this Z by A to get the number of conductors in one parallel path, and then you divide it by 2, you will get the number of turns. Now this should be the correct one. Just 1A is also going to come here. 1A is also going to come here like this. So you will get the value of IAZ upon A. This is the value you are going to get from here. Just put it here. IAZ upon A, and you will get what is the value of P. Is it clear for everybody? Just tell me in the comment section, are you able to follow this? Say yes or no. Yes. Any doubt you can ask me. Are you getting this? Suppose you have this kind of arrangement. Your armature is something like this. A number of parallel path. A number of parallel path. So you tell me, if you know what is the EMF induced in one parallel path, that is only going to be the total EMF, na? So you have to take care of only the number of turns present in one parallel path. That is the mistake I was doing. I hope it is clear for everyone. So this is all from my side, friends. Thank you so much for joining me live in the discussion. I hope this session is going to help you in understanding some of the concepts related to DC machines. Tomorrow also, let me just tell you, tomorrow I will be discussing the questions related to EMF and torque equation in DC machines. The timing is going to be same, that is 8:30 p.m. only on BYJU'S exam prep. Mr. Prasanna Kumar is asking, what is the main difference between compensating winding and interpole winding? See, the only difference is what is their objective. Compensating winding is compensating the cross magnetizing ampere turns of the armature winding under the polar region, whereas interpoles are in between the main field poles. So interpole winding is compensating the cross magnetizing effect of armature reaction in the interpolar region. The basic purpose of having compensating winding and interpole winding is we want to remove the problem of commutation. I hope you are getting that. Armature reaction and commutation. Is it clear? So this is all from my side, friends. Thank you so much for joining me live in the discussion. Take care of yourself and let us meet tomorrow 8:30 p.m. on the same channel, BYJU'S exam prep. All my best wishes for you. Thank you so much. Thank you everyone.